Imagine waking up one day to find that your city has literally nowhere left to put its trash. That's exactly the slow-moving catastrophe that hit the city of Xi'an in 2019. The Zhangkongo landfill, which was one of China's absolute largest, completely ran out of space. But here is the truly terrifying part. It didn't just fill up, it filled up a staggering 25 years ahead of schedule. In this explainer, we're going to uncover a massive engineering paradox and see how a sheer lack of physical space triggered a multi-billion-dollar industrial revolution. 25 years early. Just think about that for a second. This catastrophic early closure forced a high-stakes emergency, making the world's largest waste generator urgently ask an impossible question. What exactly do you do when you literally run out of places to put your garbage? It's not like you can just tell a billion people to stop throwing things away. So what's the solution? Well, the answer definitely wasn't just digging more holes in the ground. Instead, they built massive facilities like the Haining Expansion Project. Honestly, it looks more like a modern art museum or some futuristic convention center than a garbage facility, doesn't it? But underneath that sleek exterior, it's actually a state-of-the-art waste-to-energy incinerator. And we're not just talking about building one or two of these. We're looking at one of the most furious infrastructure booms in human history. Back in 2012, China had 122 of these plants. By 2019, that number jumped to 428. And by 2025, an unbelievable 1,137 plants. In just a fraction of a decade, they scaled up so aggressively that they now process over 80% of the country's municipal waste completely through fire. To really wrap our heads around the scale of this, we have to look at the complete infrastructural reversal that happened. Back in 2005, a massive 85% of waste went straight to landfills, and just under 10% was incinerated. Fast forward to 2024, and those numbers have completely flipped. Landfills now take a mere 5% of waste, while incineration has skyrocketed to nearly 85%. They basically eliminated raw dumping overnight, achieving a 99% harmless treatment rate. It's actually pretty brilliant how this works. How does burning trash help the grid? Step 1. Household rubbish gets fed into the incinerator. Step 2. Burning that waste generates incredibly high-temperature flue gas. Step 3. That intense heat boils water to produce steam, which then spins massive turbine generators. And finally, Step 4. You get green electricity. By 2024, these plants generated an incredible 145 billion kilowatt hours. They literally turned a landfill crisis into a sprawling power grid. But right here is where things take a wild turn. They solved the space crisis so aggressively and built so many of these futuristic plants so fast that they engineered themselves into an entirely new problem. 40%. Right now, a staggering 40% of their new multi-million-dollar waste-to-energy capacity is sitting completely idle. They are facing a glaring logistical mismatch. You've got this massive daily incineration capacity of 1.2 million tons, but the actual daily collected waste, it's only 700,000 tons. Driven by an economic downturn and a slowdown in rapid urbanization, there simply isn't enough trash to keep the fires burning. They build a beast, and suddenly, they can't feed it. To make matters even wilder, well-intentioned environmental laws actually made this shortage worse. In 2019, Shanghai introduced these super strict waste sorting regulations. This legally diverted up to 35% of highly combustible plastics and papers straight away from the incinerators. Without those highly flammable materials, the burning energy, or calorific value, of the remaining trash dropped by 14%. It got so bad that plants actually had to start buying and burning natural gas just to keep their fires hot enough to operate. And those strict laws had another fascinating, unintended ripple effect. You and I would probably assume that strict environmental regulations would naturally encourage people to reuse items, right? Well, actually, the exact opposite happened. Data show that the sheer hassle of sorting discouraged people from engaging with physical goods at all. Online resale listings among environmentally conscious young users dropped by over 8%, and overall purchase volumes fell too. It's a textbook example of unexpected policy trade-offs. So how in the world are these starving incinerator plants surviving right now? The measures are getting desperate. They're importing residual waste across provincial lines, they're taking on premium sewage sludge, and shockingly, in the ultimate stroke of irony, some plants are literally digging up waste from old abandoned landfills. Let that sink in. They are mining the exact dumps that caused the crisis in the first place just to find fuel to keep the lights on. Section 1. The high-tech evolution. When you run out of good fuel, raw desperation forces you to evolve.
Without enough high-quality, combustible trash, the industry realized they couldn't rely on basic human guesswork anymore. To survive, they had to turn to artificial intelligence. To squeeze every drop of energy out of terrible quality trash, the Chaoyang Environment Group developed a brilliant AI incineration system. First, advanced cameras and sensors visually see the exact makeup of the waste entering the furnace. Second, real-time algorithms instantly predict how that specific batch will burn, hours in advance. And third, the system automatically fine-tunes the furnace temperature and flue gas treatment. It takes human error completely out of the equation.
And the results of this AI optimization are absolutely staggering. At an 1,800-ton plant in Beijing, this visual system increased steam generation stability by an incredible 36 to 48%. Because it's running so smoothly, it pushed the electricity supply to the grid up by 4.2%. And since the burn is now perfectly optimized, the consumption of expensive emission control materials actually dropped by 3%. In a starving industry, this efficiency became their new lifeline.
Now, what's really interesting here is how the big environmental giants use this exact operational efficiency to save their businesses. Take the Jizhu project, operated by China Everbright Environment. Facing a complete crash in new plant construction across the country, they had to radically pivot their entire business model. They shifted away from building new infrastructure and poured everything into hyper-efficient operating services. And looking at Everbright's 2025 revenue shift, this survival strategy definitely works. Sure, their construction revenue crashed by 53%, but because they perfected these high-tech operation services, that segment grew to make up a massive 72% of their total revenue. By transitioning to this stable, lighter asset model, their net profit actually went up 16% to nearly 4 billion Hong Kong dollars. They defied the industry downturn entirely.
Section 2. The 15th Five-Year Plan. This entire forced technological evolution actually lines up perfectly with China's broader macro picture for the future. What started as a frantic scramble to deal with overflowing landfills has now become a calculated pillar of their national priorities for resource security and their ultimate goal of reaching carbon neutrality by 2060. The new binding targets for the 2030 circular economy are incredibly ambitious. They are legally demanding a 16% increase in overall resource productivity. They plan to utilize 4.5 billion tons of bulk solid waste, and they are targeting 510 million tons of secondary resources to be recycled annually. The mindset has completely shifted. They are no longer just managing waste, they are mining it as a critical national resource.
And the economic scale of this is breathtaking. By 2030, this transition is projected to create a massive circular economy industry worth 8 trillion RMB. Let me say that again, 8 trillion RMB. They have permanently transformed municipal waste from a toxic public liability into a highly lucrative, high-tech commodity. Which brings us right back to the resolution of our opening mystery. China didn't just find a new place to put its trash when that landfill in Xi'an overflowed 25 years early. Through a chaotic mix of frantic overbuilding, unexpected policy backfires, and sheer industrial desperation, they accidentally forced themselves into building one of the most advanced, highly efficient circular economies on the entire planet, from a trash crisis to an efficiency empire. It leaves us with a fascinating paradox to consider. Does true innovation only happen when we literally run out of options? When the landfills are entirely full and the high-tech incinerator fires are dying from a lack of fuel? Is that the only time we finally figure out how to build a better, smarter system? Think about that as you reflect on this explainer, and we will see you in the next one.